Okay, for the following example, section 2.2.RA-6, the data below represent the per capita average disposable income after taxes for 25 randomly selected cities in a recent year. We want to be able to describe the shape of the distribution. Now, in order to describe the shape of the distribution, we have to construct a frequency histogram of the data. So, in order to do that, okay, we want to be able to use 30,000 as our lower limit of the first class, and then we're going to use a 6,000 for our width. So I'm going to go ahead and pull that up here, and we're going to open up this data in StatCrunch. So we're going to go select Graph and then Histogram, select the column, and we're starting at 30,000, and we have a width of 6,000, and then we're going to go ahead and compute. Now we can also put per capita income down here, which I've already written in there from a previous exercise. So we're going to go ahead and select compute. So I'm going to copy and paste that and put it into our exercise. Okay, so in this graph here, it is in thousands, but this is the same one, only that it's in thousands, written in thousands. This is abbreviated for per thousands. So now we need to figure out how to describe this uniform distribution. Now recall that in a uniform distribution, the frequency of each value of the variable is evenly spread out across the values of the variable. In a bell-shaped distribution, the highest frequency occurs in the middle, and frequencies tail off to the left and the right of the middle. Now, in a skewed right distribution, the tail to the right of the peak is longer than the tail to the left of the peak. In a skewed left distribution, the tail to the left of the peak is longer than the tail to the right of the peak. And notice that in a frequency distribution produced over here, there's a tail to the right of the peak, but not to the left. So again, if I was talking about a uniform distribution, then that means I would have something that would look like this. Okay, for a bell-shaped, I would have something that may look like this. And the reason why they call it bell-shaped is that you can create this bell-shaped. Okay? And then if it's a left tail, that means it's starting here and ending up over here, which means you would have something that looks like this. Okay? And if it was right tail, then you would have something like this, where you have that, and therefore it's tailing to the right. Okay, so in our situation here, if you take a look at this and draw, you can see that the curve ends up tailing to the right, and that's why the distribution is skewed